So in this video we're doing two things. The first is to introduce some MIDI input objects. We've looked at MIDI output objects, or at least one of them, to control our internal MIDI synth on the computer, but we might want an external controller, like a MIDI keyboard, to control things in Max. And there are various different objects that will allow us to do that, so we'll have a look at those first of all. And then the second part of the tutorial is to introduce some very basic things in MSP so that we can get Max to produce the sound for us rather than the internal MIDI synth. And obviously it's the ability of Max to produce sound on its own that makes it really powerful. I've asked you to copy across this code into a patch, which I've done already, and these are some objects that we can use. So you'll notice there's one called noteIn, there's one called CTLIn, and that refers to controller information, and then one called bendIn, which refers to bend information, and they refer to different types of MIDI data, all of which will come from a device such as the one I'm using here, which is the Novation launch key. So on the launch key we have various different controllers and obviously keys. The keys that you see here would send note information, which is what we've been using predominantly so far to send notes to the internal MIDI synth. The drum pads up here also send note information. And we'll come back to that in a minute. Then we have a variety of controllers, which are the dials at the top here, and the modulation wheel and the volume control, and also these transport controls on the keyboard as well. And then finally the bendIn would take data from this pitch bend wheel. Why that has its own separate control is something I probably won't go into in this video. I might say something about it. But we'll come back to that in a bit. So just as before, when we double-clicked on the note out and, oops, need to lock the patch, we received a list of all the devices that Max could communicate with, and the one we've been using again is this one, at least if you're on the Mac, AU DLS synth. On a PC it will be something equivalent. You'll notice that the list has got longer since the last time I did a video, and that's because we've got this launch key in here. So I've already plugged it in and it's already recognised by Max. There's no point in me trying to send data to the launch key because it doesn't produce any sound on its own, but nevertheless it has an entry here, and that's probably because you could send data to it to get these drum keys to flash, and possibly set certain aspects of the functionality of the keyboard, but we're not going to do that. If I double click on noteIn, then we get that list again, and obviously the AU DLS synth doesn't appear there, but the launch key does. Now you'll notice that all devices by channel is ticked, and that's because Max will accept data from every device that's listed here. But if you wanted to be more specific, you could get it to just accept entry from only the launch key, but I'm going to leave it on all devices by channel. So you'll notice with noteIn that there are 3 number boxes attached to it. These aren't actually doing anything, they're just displaying, and all 3 of the outlets are connected directly to the 3 inlets of note out. So everything that happens on the keyboard is going to be routed directly out to the AU DLS synth. So Max is just operating as a kind of through device at the moment. It's not actually adding anything to the kind of functionality. It's just sending the data directly through. And as I say, we looked at earlier, if I hit a key, then noteIn will recognise it. So I hit a key on the controller, and we get the note middle C. And you might remember that when we were sending data out to the internal synth, we were sending note number and velocity information. and usually what we had was an additional argument in note out which was sending the channel information, but in this case it's being sent through the third outlet of note in to the third inlet of note out. So that's something to remember, is that in all MIDI objects, the rightmost outlet and inlet deals with channel information, and then the first two, or first one in the case of bend in and bend out, those inlets and outlets deal with the other kind of specific information that is pertinent to whatever kind of object it is, so note in or control in or bend in. So in this case I hit the key, the note was middle C, so we got the note number 60 and the velocity of 90. So now I'm still holding the key down. When I release it, then we get a note number 60 but a velocity of 0. So we're getting note off information when I release the key. And that's important because we need the MIDI device or the MIDI synth that we're sending stuff to recognise that we've stopped the note. So there's a note on information and then there's note off information. So again, I'll hit another key. This time we got an E, which is the note number 64, and a velocity of 112. Once again, when I release the key, we get a velocity of 0. So, as we've already established in previous tutorials, each note is represented by a number. And there is a consistency through MIDI that the note C will always be represented by, middle C will always be represented by the note number 60. So that's note in information. From the keys on the keyboard, if I hit the drum pads, then we also get information into note in. This time I'm hitting the top left pad, and we're getting the note number 40 and a velocity of 100. Notice that the channel number has jumped to number 10, which, if you remember from the first tutorial, is the MIDI percussion channel. So as you would expect, the pads are always kind of routed to percussion sounds, hence the percussion channel by default. Again, when I release the pad, then it goes back to a velocity of 0. And I can hit other pads and we get different note numbers and different velocities depending on how hard I hit the pad. But still we're on channel number 10. So reliably, because we are sending to channel 10, we actually get those MIDI percussion instruments as you would expect. So it's still being routed to general MIDI percussion. And we're getting a bass drum sound when we get the note number 36, and we're getting a snare when we hit the note number 40, and equivalent percussion sounds or other percussion sounds when we hit other keys or pads. So that's keys and pads which are being sent to note in. Just before I move on, I said that we could change some of this information. So at the moment it's being routed straight through note in to note out. If I were to unlock the patch and I add plus 12, for example, then and then hit the note middle C on the keyboard again, then notice that we are adding 12 to 60, which means we get 72, and we get an octave above. So instead of this note sounding, we get what is the equivalent of this note sounding. So you can, obviously you could perform some intervention between the note in and note out in order to change that data and before it gets sent to the internal synth. So moving on, control in and control out, well they're both related to controller information, which I pointed out before, the kinds of controllers you might be receiving data from. And once again, looking at the outlets, the rightmost outlet has the channel number, and then moving leftwards, the middle outlet gives us the controller number. So each one of these controls is allocated a number. So the modulation wheel by default is given the number 1, the volume control is given the number 7, and this is just a MIDI convention. These pots up here, well, on this keyboard they are given numbers between 21 and 28, as we'll see when I start wiggling them, and then these buttons over here are also given controller numbers. So all of those so that the kind of addresses for those controllers are marked from the center output, and then the values of each of those controllers are sent out of the leftmost one. If I move the modulation wheel, we see that controller number 1, as I said before, and then we have the value of 0 to 127. So once again, as with all MIDI data, we are dealing with numbers from 0 to 127. The volume slider, as I said, is given the controller number 7, and again, as I wiggle it, we get the value of that controller coming up in the leftmost outlet. And then all of these pots across the top, we've got the first one, second one, third one, and so on as I wiggle them. And then finally, if I hit the buttons on the right hand side, now these don't have values between 0 and 127, because they only have two states. They either have when you hit them or when you release them. So when I hit one, you'll see that, oops, there we go, we get the controller number here, which is 112, but we only get a value of 127. So we only have two states, 0 or 127, either hugely on or completely off. So when I release the key, we get the value of 0. And when I hit another one of those, we get a different controller. So I'm pressing the stop button now. We're getting controller number 114 and velocity of 127 when I hit it. When I release it, we get velocity of 0. So that's fine. Once again, all of this stuff is coming in on channel number 1. As to these numbers, these controller numbers seem rather arbitrary on these keyboards. Well, yes, that's just how it is. Again, there are certain things which have conventions, like the modulation wheel and the volume control, because they've been around for ages. But some of these other ones have a more kind of arbitrary number, which is fine as long as you're using the same keyboard all the time. You can specify, and we'll look at how we can kind of constrain the input from the controller numbers later on, or the controllers later on. Yeah, I won't talk about that now. I'm going to move on. Oh, except that I haven't actually tested this yet, so let's do that. If I press the note middle C again, we'll get the piano sound an octave above, because remember we've transposed it. But if I move the modulation wheel, we'll hear that it starts to modulate, and that's because the internal MIDI synth on the computer recognises that controller number 1 should be a modulation control. Similarly, if I change the volume control, then we get an overall volume shift. So again, controller number 7 controls overall volume. So that all works well. But none of these other controllers at the top here would be allocated to anything yet. So we'd have to allocate them to something ourselves. And again, we'll try doing that later. So yeah, moving on. Bend controller. This one only has one outlet, aside from the channel number outlet. But basically it operates in the same way. You remember, well, you'll know from your keyboard that there's always a kind of central state that it defaults to, and I've just wiggled it, and we see that when it's hovering at that point, we have a static value of 64, which is obviously halfway between 0 and 127. And as I move the pitch bend wheel up, then it goes towards 127. When I move it down, it moves towards 0. And as we would expect, when I hit a key, then that data is sent directly to the AU MIDI synth, and we hear the result. So those are basic controller sources on our keyboard. There's one thing I haven't shown you yet, and this was a bit of a kind of, not a red herring, but it was slightly different because it doesn't have an input. There is such a thing as a PGM in, but there's no particular reason to use it on from the keyboard at the moment, at least. PGM out refers to MIDI programs. So to get different sounds on your from a MIDI synth, you'd have to send it a different program number, and each program number by default is given a general MIDI instrument sound. So program 1 is invariably a piano. I'm going to get rid of this because it's slightly misleading. Let's go back to our C being middle C. Is a piano sound. If I move to a different number, we get a different instrument, and there are 127 different instruments. Etc. So those are our basic MIDI objects. Now these can be used to control anything because we can constrain the data. So I'll show you how to do this now, but we'll have an application for it a little bit later. So let's say we want to use this pot here to control a slider in Max. So let's make a slider first of all. Drag one in. There's a slider. Oops. So I can connect the controller output, the first outlet of that, to the slider, and I can move this pot, and it sends data to that slider and moves the slider. Great. The thing is that if I were to move this slider here, then it would also change the value of that slider. Sorry, if I were to move this pot, it would also change that slider. And the same is true of any of them, or even the mod wheel, or even the volume controller. So all of them are being sent to that slider. So that's all very well, but what happens if I want another slider, but I want a different pot to control that slider? So what we want to do is to constrain CTL in to only receive data from one particular pot, so that we can send it to one particular slider. And the way to do that is simply to know the controller number from which it's being sent, so which controller number that pot is being sent to, and we can do that using arguments. So if I put in, we know that this controller is number 21, whoops, because when I wiggle it we get the controller number 21 coming up here. So all we need to do is to add that as an argument along with the channel number from which we want it to come, and that constrains the data. So notice we lose all of the rest of the outlets because we don't need them anymore. We've already said all we want is to have stuff from controller number 21 and from channel number 1, so the rest of them are redundant. And now when I wiggle this pot, we're not getting data from any of the other pots. I'm changing pot number 2 at the moment and nothing's happening. But we do know, so if we want that particular pot to control something else, all we need to do is to copy this controller here and put in controller number 22, because we know that this controller is number 22 because we tested it earlier. We wiggled it and then out of the middle outlet we got the number 22. So this time we can put in controller number 22, channel number 1, connect that one to a different slider, and then I can wiggle the two independently and they both get that data. So you can, using that method, get different controllers to control different parameters, for example, in a patch, and get them to do what you want them to do. So we'll be looking at that a little bit later, but for now I shall stop.